Wyzant. This problem is asking us to find the equation of the line tangent to the graph of f at the indicated value of x. We get our f of x equals 10e to the x plus 2x, and we need to find the graph of the line tangent when x is 0. All right, so first of all, I used Wyzant's plotting utility to write out our equation and then get a plot of the equation, which has a nice kind of curve like this. Then we'll notice that we're trying to find the line tangent to x equals 0. So so x equals 0 along the y-axis, which is to say there's no movement left or right. We're quite dead in the center here. And it's a little hard to see, unfortunately, because it kind of cut off. But it looks like our line tangent is going to kind of look something like this, which is to say it's going to be the line with a slope that reflects the slope at the point where x is equal to 0. So kind of a lot of info, but we're going to break it down in just a minute. So first of all, we know that the tangent line is going to have this type of equation, y equals mx plus b. But what are all these variables? I don't know why we're introducing even more variables, and it's kind of harkening back to Algebra 1 or Algebra 2. We know that m is slope, or rise over run, and b is the y-intercept. In other words, wherever x is equal to 0, y has some value b. And based on the way that this line looks, I kind of am predicting that the slope is going to be positive and pretty big, maybe something like 10 or 20, not quite sure. And the b, or y-intercept, is also positive and pretty tall, like 10, not quite sure yet. All right, another way to write slope is that it's the difference between y2 and y1 over the difference of x2 and x1. This is the same as rise over run. But in calculus, we start to think about infinitesimally small differences, which is basically to say the distance between x2 and x1 is approaching 0. And of course, you can't divide quite by 0, so instead we call this dy over dx. All righty. And if I want to find dy dx, I actually just differentiate the original function, which to me would mean differentiating e to the x, which again is e to the x, keep the 10 intact, and then differentiating 2x to get positive 2. All right, I think we're done there. Then I'll notice that this is supposed to be my slope. The derivative kind of represents the slope at a point. So the point is where x is equal to 0. So I can actually plug 0 in. E to the 0 looks a little funny, but remember, anything raised to the 0, anything that is not 0, I believe, raised to the 0 is 1. So 10 times 1 is 1, plus 2 is 12. So our slope when x is 0 is 12. So our prediction holds true, that the slope is positive and pretty big. Next, we need to solve for the y-intercept, the b, to finish out our linear equation. So we know that y is going to be 12 times x plus b. This 12 is the same as this 12. And from there, we can kind of remember that this needs to pass through the point 0, 10. That's because if I plug 0 in for x, I get 10 times e to the 0, which is 10, plus 0 is 10, obviously. And that needs to be the same as maybe the point that my line is passing through, because they need to sort of intersect at that point. Then I can say that 10 is our y value, equals 12 times 0, which is the x value, plus b. So b must have been 10. So I think when you put it all together, you'll get that y equals 12x plus 10. And it should look exactly like the blue line. Oh, I'm sorry. Here we go. Yes, it looks exactly like the blue line we predicted earlier. Positive, big slope, and a positive y-intercept that's also pretty big. I hope that helped. Thanks.